All right, today we're going to talk about a couple things. We're going to talk about cones. We're going to focus in on cones today. And we're going to talk about lateral and surface area. Now, lateral is something we haven't really mentioned yet, but we could have been finding this whole time. So lateral is everything but the bases. So it's all the surfaces except the bases. So it's the area of all surfaces except any bases. Now the reason I say any bases is because let's say we had a cylinder. So if I asked you for the lateral area of the cylinder, remember when we found surface area we said we had two circles and then we had that rectangle, right? The soup can label, if you will. Well, if you're just asked for lateral area, you don't have to add in those two circles. So you would only have to find that rectangle that wraps around. So lateral is everything except for the bases. Surface area means everything. So if I asked you surface area, you would have to add in those two circles as well. All right, so that's the difference between lateral and surface area. So in terms of a cone, your surface area is everything, which means it's this part and the circle on the bottom. Your lateral area is just this part, which is what we're going to talk about today. So if you opened up a cone, this is what you would see, this shaded part here. You'd have a circle, that was your base, and then the cone would actually open up into basically a sector of a circle. So this part's not here. So how do you find the area of that? And that's where you have a special formula. So for lateral area, your formula is pi RL. L stands for slant height, and I did mention that a couple days ago. L does exist. L is a slant height. So the height of a cone drops through the center. The slant height goes down the outside. So the height of a cone drops through the center. The slant height goes down the outside. And this is just a formula, pi RL. If you wanted to find total surface area, if you wanted to add in that bottom, that base, you would add in that area of the circle, pi r squared. So that's when you see down here, surface area is lateral area plus the base. Lateral area plus the base. So let's use it. Find the lateral area and surface area of the right cone. All right, so we have lateral area is pi r L times the slant height. So my radius, my diameter is 16. Half of that would mean my radius is 8. And they did tell you your slant height was 10. Forgot to mark that. The slant height is 10, so we know it's 10 because the problem told us. So here we have 80 pi, and we're going to leave it in terms of pi for right now. So 80 pi centimeters squared because we're talking in terms of area. They also wanted surface area. So surface area is lateral area plus your base. Well, your base is a circle, so pi r squared. So my lateral area was 80 pi. All right, that was all this stuff wrapping around. And we want to add in that circle on the bottom. So my radius was 8 still. So we have 80 pi plus 8 squared is 64 pi. And when you add those up, 80 plus 64, you wind up getting 144 pi centimeters squared. So again, understand the difference. Lateral area is just all the wrapping around. Surface area is the wrapping around and that circle on the bottom. So the wrapping around is lateral area plus the circle on the bottom. Now it does say and round to the nearest centimeter, square centimeter. So we're going to go ahead and round as well. So 80 times 3.14. We're going to type it in our calculator, 80 times 3.14, and we get 251.2. It says round to the nearest square centimeter, which is about 251 centimeters squared. So square centimeter is a whole number. All right, down here, 144 times pi. We type it in our calculator, 144 times 3.14, and we get 452.16. And again, to the nearest square centimeter would be 452 centimeters squared. So here's lateral area exact, leave in terms of pi, and round it to the nearest square centimeter. And here's surface area exact and rounded. Okay. Now sometimes they don't give you all the information you need. Notice here my slant height is missing. So before I start this problem, I need to find that slant height. So notice you have a right triangle here. Pythagorean theorem, a squared plus b squared equals c squared. C is always across from your right angle, which is my slant height. So we have 15 squared plus 8 squared equals c squared. Let's do a little math here. 15 times 15 gets me 225. Oops, sorry, that's 225. 8 times 8 is 64. So 225 plus 64 is 289. And your last step whenever you're doing Pythagorean theorem should always be to take that square root, right? We want c, not c squared. So the square root of 289 is 17. So you know your slant height is 17 inches. Now that we've done that, we can do our problem like normal. So lateral area is pi r L. Unfortunately, this is a formula you just have to know. Your formula sheet for EOC does not give it to you. Radius is 8. Slant height we just found was 17. So we do 8 times 17, and we get 136 pi inches squared. So there's my exact lateral area. Again, I always jump to surface area. Once I have exact, I go ahead and jump to surface area first, because remember it's lateral area plus the circle on the bottom, right? Lateral area plus the circle on the bottom. So our lateral area was 136 pi. So I don't want to round this yet because I'm going to plug it into my formula for surface area. Pi r squared, there's still 8. We have 136 pi plus 64 pi. So we have 136 plus 64 pi makes 200 pi inches squared. So these are both of my exact answers. Now I'm going to go ahead and round 136, because it did say round to the nearest square centimeter again, times 3.14. I'm going to type that in my calculator, 136 times 3.14. I get 427.04, which to the nearest square centimeter would be 4. Oh my goodness, I cannot write today. 427 centimeters squared. Here, 200 times 3.14. 200 times 3.14 is 628 exactly, so we're going to leave it centimeters squared. All right, so let me pull up the worksheet. All right, this is your worksheet. I did go ahead and put cylinders on there just for review, because to be honest, the two hardest ones for surface area are cones and cylinders, because they have that weird curved surface. So here we learned that that curved surface for a cone was pi RL. Quick recap of cylinders, just to make sure you guys are good on this. Cylinders, you had the two circles, and then you had that rectangle that wraps around, right? Think of a soup can label. So your two circles, so area of a circle is pi r squared, right? So in this one, pi, my radius is 7 squared, 49 pi. And then the area of that rectangle, and if you have to draw it out, draw it out. So the height of my rectangle is 10. Now the length of my rectangle, remember it wraps around the circle, so it's circumference. It's the circumference of that circle. So you want to think in terms of circumference, which is 2 pi r. So 2 pi, and my radius was 7. So here you have 14 pi times 10, you get 140 pi. And then you add them all up. So total surface area is 49 pi. There's my top circle and my bottom circle and the rectangle that wraps around. So we're going to say 49 plus 49 plus 140. Oh, I messed up. 49 plus 49 plus 140. And I get 238 pi. Oops. 238 pi. Now this does say round to the nearest hundredth, so we're going to actually do 238 times 3.14. And to the nearest hundredth would be 747.32. It's actually exactly that, which is rounded to the nearest hundredth. Feet squared, because we're talking in terms of area. So just wanted to remind you about surface area of a cylinder in case you forgot. But the cones are exactly like what we did in the notes. And I think they give you the lateral area on all of these, so, or not the lateral area, the slant height, sorry. Now the second page is volume, and I just wanted you to practice. So remember, a cylinder has two bases, so you're in the first volume formula, big B times H. Area of the base, my base is a circle, so really area of a circle is pi r squared. Big B is pi r squared times H. And you plug into that formula, okay? Here, cone has one base, so we're in that second formula, big B times H, 1/3 big B times H. Again, our base is a circle, so big B is pi r squared, still times the height. So I just wanted to show you, I just wanted you to practice changing those formulas, so this should be the formula that you're using for a cylinder and for a cone. All right, but do those formulas. Yes, use pi because it says round to the nearest hundredth. So like, for example, this one, I'm not going to do it out, but you would do 3.14, your radius, be careful here. Your diameter is 4, so your radius would be 2. So 3.14 times 2 times 2 times my height, which is 6. And whatever that is, round to the nearest hundredth. All right, finished up. Remember the first side's surface area, second side's volume.